Okay, this is quiz 5. The first question reads, find the slope of the function f of x equals 6x squared plus x plus 1 at the point 1, 8. Okay, obviously the slope of the function, that's just the slope of the tangent line, which we know is the derivative. So if we take the derivative of f of x, f prime of x, now according to the power rule, we know that we need to bring down the power and multiply by that power as a coefficient. So we have 2 times 6, and then we have x, and then the power we just subtract 1. So we have x to the 1, which is just x. And then the derivative of x, we can again apply the power rule. So if we pull down the 1 that's here, we get 1, and then we have x to the 0, which is just 1. So the derivative is 12x plus 1. Now in order to find the slope at the point 1, 8, we need to plug in x. So we get that f prime of 1 is equal to 12 times 1 plus 1, which is 13. So the slope of the function f of x equals 6x squared plus x plus 1 at 1, 8 is just 13. Okay, now they ask us to find the derivative of the function e to the x times the quantity 6x squared plus 2. I've written the product rule here. The product rule says that the derivative of a product is just the derivative of the first function times the second unchanged plus the first function unchanged times the derivative of the second. So we get that f prime of x is the derivative with respect to x of e to the x times 6x squared plus 2, and then plus e to the x times the derivative of 6x squared plus 2. Okay, if we apply the rules we know the derivative of e to the x is just e to the x. So we get e to the x times 6x squared plus 2 plus e to the x times, now the derivative of 6x squared plus 2, again, when we take the 6x squared, we get 12x. We're using our power rule just like we did before, and the derivative of a constant 2 is just 0. So overall, we get that the derivative of this function is e to the x times 6x squared plus 2 plus e to the x times 12x. Okay, now we need to take the derivative of the function f of x is equal to 8x squared minus 6x plus 2 all over x cubed. I've again written the quotient rule here. The quotient rule says that the derivative of two functions divided, or a quotient, is the derivative of the top function times the bottom function unchanged minus the top function unchanged times the derivative of the bottom function all over the bottom function squared. Okay, so if we apply that here, we get that f prime of x is equal to the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay, now the derivative of 8x squared minus 6x plus 2, we just need to apply the power rule. So the power rule says that we pull down a 2, so we have 8 times 2, or 16, times x to the 2 minus 1, which is just 1. Now, again, we apply the power rule for negative 6x, and we get minus 6 times 1 times x to the 0, which is just 1. So this whole thing is just 16x minus 6 times x cubed minus 8x squared minus 6x plus 2 unchanged times the derivative of x cubed. Now the derivative of x cubed, we just apply the power rule, we pull down that power, so we get 3 times x to the 3 minus 1, which is 2. So we get on top 16x minus 6 times x cubed minus 8x squared minus 6x plus 2 times 3x squared. And that's all over the bottom squared, which is x cubed squared. So we get x cubed times x cubed. Now we can simplify when we have two exponentials with the same base, we can just add the exponents. So overall, we get 16x minus 6 over x times x cubed minus 8x squared minus 6x plus 2 times 3x squared all over x to the 6th.